All right, so this first video is on the first packet of notes that I gave you. First section is inductive and deductive reasoning. So inductive reasoning is the process of arriving at a general conclusion based on observations of specific examples. Conjectures, also known as hypotheses or educated guesses. The conclusions generated from inductive reasoning are also called conjectures. And if the conjecture is false, it is called a counterexample. So here we have examples of inductive reasoning. We will be having patterns that are established, and we have to figure out what the patterns are and then be able to calculate what the next number would be. That's mainly what this section will be about. Those examples in your homework or those problems in your homework will be on identifying patterns and then generating the next number. The more you do this, the more you'll become comfortable with doing so, and the more you start to see what your options are when you go to calculate. So, of course, you wouldn't have the patterns down here. You just have the numbers 3, 12, 21, 30, 39, and then identify the next number. So you see that adding 9 to each number is how we get to the next number. So you add 9 to the final number, and that gives us 48. Here, the pattern that's established is you multiply the first number by 2, you'll get 6. Then multiply that number by 3, you get 18. And then you continue that pattern of multiply by 2, multiply by 3, multiply by 2, multiply by 3. And multiplying this last number by 3 gives you 648. Next one, you'll multiply by 2, multiply by 3, multiply by 4. Then we see we multiply by 2, 3, 4. Again, we have that same pattern. So you multiply the last number by 2, and that gives us 3456. Next one is a little different. See here, we're adding the 2 previous numbers to get the next number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. So to get the final number, 13 plus 21 is 34. So deductive reasoning is the process of proving a specific conclusion from one or more general statements. A conclusion that is proved to be true by deductive reasoning is called a theorem. So this section doesn't really involve much with deductive reasoning, but it just gave you an example just to see the difference. So one player to another in a Scrabble game, you have to remove those 5 letters. You can't use Texas as a word. So your deductive reasoning will start off with recognizing that all proper names are prohibited in Scrabble. Texas is the proper name, therefore Texas is prohibited in Scrabble. So once again, it's the process of proving a specific conclusion from one or more general statements. Next section, estimation and graphs. So here we're looking at place values. Place values are almost symmetric about your decimal. And when I say almost symmetric, symmetric means whatever's going on one side is reflecting on the other side. And I say it's almost that way is because on the left side of your decimal, you see we have the ones place, but you do not have the ones place on the right side. Outside of the ones place, you do have the same place values are being reflected. You have the tens and tenths, hundreds and hundreds, thousands and thousands, 10,000s, 10,000s, and so on. It's just that you have the ones place on the left side of the decimal. You do not have the ones place on the right side of the decimal. So we're looking at rounding first. First, you're going to locate the desired place value to round. Then you look to the right of that value. If the value to the right is 5 or greater, you round up. If the value to the right is less than 5, you leave that value the same. All right, so let's say if we had this number, 6,751,893.24159. And we're going to round to the nearest hundredths. The reason why I underline the TH here, the THS, is because if it's hundredths, that means it's to the right of the decimal. If it does not have the TH, then that means it's to the left of your decimal. So hundredths place would be this 4, that's to the right of your decimal. So now you look to the right of that 4 and it's a 1. Since it's less than 5, that 4 stays the same, and everything to the left of your 4 turns into zeros. And so that's what we have here. 4 stays the same, these zeros, these numbers turn to zeros, and notice they're scratched out. We do not need them. If we want to write our value in the simplest form as possible. Zeros that are to the left of your decimal, and there's nothing else, to the right of your decimal, excuse me, and nothing else behind them would be removed. And so that's what I have here, and I should have put a slash with the equal sign. 400, let's say if you have $400 in your account, and they told you it was equal to 4, you would not agree with that, of course, because those zeros are to the left of your decimal. But let's say if you had 400.00, that is the same thing as $400 without the 0.00. Those zeros to the right of the decimal do not matter, but the zeros to the left of the decimal do matter. So just be careful with that. So let's go to the next one. We're going around to the thousands place. Notice there's not TH, so that means it would be to the left of your decimal. That would be the 1. Look to the right of the 1. That's an 8. Since that 8 is greater than 5, you're going to round the 1 up. So that's what we have here. 6, 7, 5, 2. Everything to the right of that 2, it turns into zeros. And then the zeros to the right of the decimal, you can drop because they don't carry any value. Estimating by rounding. So let's say we had the example in which you purchased bread for $2.59, detergent for $2.17, sandwich for $3.65, an apple for 47 cents, and coffee for $5.79. The total bill given was $18.67. Is this amount reasonable? So this book, the way they want you to handle estimation is that you're going to round all of your values to the highest value and to the same value, a highest place value into that same place value. So in other words, $2.59 would be rounded up to $3 because the 5 would take the 2 up to 3. $2.17 will round down to $2 because the 1 allows the 2 to stay the same. This 6 will take the 3 up to 4. Now here we have to be careful. Remember, we're going off what the book wants you to do, not necessarily what you would do in the grocery store on your own. If we had this bill, we want to round our values for easy calculation, and that's what we're doing this estimation for. We would at least turn this to 50 cents or maybe even round it up to $1 to make sure that we are covered when we get to the cash register. But if we're going off what the book wants us to do, we would round the highest place value, and the highest place value is 0 here. So we look to the right of the 0. The 4 will not take the 0 up. So actually the 47 cents will round down to $0. Once again, if you were doing it on your own, you probably would take it up to 50 cents or up to an even $1 to cover that. But this is how the book wants you to calculate estimation. Then this $5.79 will round up to $6. Add those together, you get $15. So that's how you get your easy calculation. That $18.67 was not reasonable because here we're getting $15 as an estimation. And if we just add these values straight up, we see we get $14.67, which once again rounds up to $15. So that's how you would handle your estimation. Let's look at another example. A carpenter who works full-time earns $28 per hour. Estimate the carpenter's weekly salary. So this problem wants you to come in with a little bit of pre-knowledge. They assume you know full-time is 40 hours a week. And then also, don't forget we're estimating. It tells us to estimate. So that means we take the $28 per hour and round it up to 30. So then you would do 30 times 40, which would just be $1,200 a week. All right. Next one tells us to estimate the carpenter's annual salary. So annually means that there's 52 weeks in a year. Because remember, we have this $1,200 per week. So if we know how many weeks there are per year, we'll be able to calculate the annual salary. There are 52 weeks per year, but remember, we're doing estimation. So we'll take that 52, round it to 50. Even though in our own calculations, we don't want to shortchange ourselves 2 weeks. Once again, this is what the book wants you to do in order to get an estimation. So we'll do 50 times the 1,200, which would be 60,000. So he will estimate the carpenter will make 60,000 annually. All right. This right here was just how our test is set up. Test 1 is 1.1 through 1.3 and 8.1. And then test 2 is 9.1 through 9.3. And that's my email address. Problem solving. So we have step 1, understand the problem. Step 2, devise a plan. Step 3, carry out the plan and solve. Step 4, check. So these problems in this section, you don't have to create an equation. When we get into chapter 6, they will be asking us to do so, but not necessarily here in chapter 1. So let's look at the first one. By paying $100 cash up front and the balance at $20 a week, how long would it take to pay for a bike that costs $680? So you're paying $100 cash up front. So you would take 100 out of that 680, which would be 580. Then you're paying $20 a week. So you divide it by 20, and that'll be 29 weeks. All right, here, suppose you are a programmer for an automatic gate for a 50-cent toll. The gate takes exact change only, no pennies. How many coin combinations must you program? So whenever you're doing something like this, you want to make sure that you're being systematic in how you do so and how you calculate, so you won't leave out anything or any combination. So there are 4 different types of coins you can use. Remember, it said no pennies, but you can use half dollars, quarters, dimes, and nickels. So a half dollar is 50 cents by itself. So you use the 50-cent piece, and notice you wouldn't use any other coins in combination with that. And then that exhausts all your possibilities of using half dollar. So you would not use this column at all throughout the rest of your combinations. Then you look at quarters. It exhausts all the possibility of using your quarters. So 2 quarters is 50 cents. No other combinations involved. Then here, 1 quarter, 2 dimes, 1 nickel, 1 quarter, 1 dime, 3 nickels, then 1 quarter and 5 dimes. After you're done with the quarters, then you move on to dimes. It exhausts all of your possibilities with your dimes. You have 5 dimes and nothing else. Then 4 dimes, 2 nickels, 3 dimes, 4 nickels, 2 dimes, 6 nickels, 1 dime, 8 nickels. So that exhausts all your possibilities using dimes. And then for the last combination, you just have 10 nickels. And then altogether, that would be 11 combinations. So like I said, whenever you're doing something like this, make sure you're systematic in your thought process and listing so you don't leave out a combination. All right, here we have 4 runners are in a race. Maria, Aretha, Debbie, and Thelma. Points are awarded to first and second place. How many different arrangements of first and second place are there? So we're only looking at first and second place, not first and fourth. So what you would do is examine all of your possibilities, with each one of them coming in first, and then the other ones coming in second. So if Maria came in first, you're looking at Aretha coming in second, Thelma coming in second, or Debbie coming in second. Then you would look at Aretha coming in first, then Maria, Thelma, Debbie, and then you do the same thing for Thelma and Debbie, and you'll see when you give an count for each one of these possibilities, you'll have 12 altogether. All right, one more. Your lecture wardrobe is limited. Just 2 pair of jeans, blue and black, and 3 t-shirts, beige, yellow, blue. How many different outfits can you create? Once again, be systematic. Start off with blue jeans. You put on blue jeans. We only have 3 other shirts that we could use, or 3 shirts that we can use. Beige, yellow, blue. And then put on your black jeans. You have 3 shirts to choose from, which beige, yellow, and blue once again. So altogether you have 6 possible outfits or 6 possible combinations that you could create. All right. Last one, percents. If you want to convert a decimal to a percent, first thing you do is locate the decimal, then move the decimal 2 places to the right, place your percent sign. So if I have 0.25, move your decimal 2 places to the right, it's 25%. If I have 0.7, move it 2 places to the right, make sure you use a 0 as a placeholder, that'll be 70%. And then here 3 as a percentage would be 300%. Moving 2 places to the right, use 2 zeros as placeholders. Percent to decimal, you locate the decimal, move your decimal 2 places to the left, and then remove the percent sign. So if I have 39%, move it 2 to the left, that's 0.39. If I have 1.2%, move it 2 to the left, 0.012. Once again, use zeros as placeholders, Then 0.8%, 2 to the left, be 0.008. All right, fraction to percent. Convert your fraction to a decimal by division, then convert your decimal to percent. So if I have 5/8, you don't necessarily have to do long division. You can throw it in the calculator. I think someone asked me about the long division process, and that's why I went ahead and did it here. 5 divided by 8 is 625, and then move your decimal 2 places to the right, like we mentioned before, that's 62.5%. So once again, just convert your fraction to a decimal by division, and then move your decimal 2 places to the right. All right, sales tax problem. Suppose that the local sales tax is 7.5%, and you purchase a bike for $894. First, how much is the tax? How much tax is paid? Then, what is the bike's total cost? So, sales tax. If you want to calculate sales tax, you take your tax rate, multiply it times the item's cost. So, whenever you want to calculate what percentage, make sure you convert it to a decimal first. So that 7.5%, move your decimal 2 places to the left, is 0.075. Then we multiply that times the 894, and the sales tax would be $67.05, $67.05. Total cost is going to be your items cost plus the sales tax. So it's $894 plus the 67.05. That would be $961.05. Discount. A computer with an original price of $1,460 is on sale at 15% off. What is the discount amount? What is the computer's sale price? So the discount amount, the discount rate times the original price. Our discount rate was 15%. So move the decimal once again, 2 places to the left to convert it back to a decimal. That's 0.15 times the 1460. That'll be 219. There's your discount amount. Then if you want to find your sale price, you take your original price minus the discount amount, which would be 1460 minus 219, and that'll be 1241. Let me know if you have any questions or anything you see in your problems or anything you saw in this lecture.